Okay, so we're going to graph basically fractions with variables. Okay, and so we look at this kind of notation in calculus a lot, this idea that we have this limit. So we'll talk about what that is. But essentially, if I told you or asked you to plug in this number, how would you say that number? Let's suppose say 0.1. What is that number really? 1/10. So lots of times we try to avoid fractions, and fractions really make math easier. If I looked at this fraction versus this fraction, what one could you solve without grabbing a calculator? The first one with the decimal or the second one with the fraction? What is it equal to? What does this tell you to do? So it tells you to not make it division anymore, make it what? Multiplication. And you're going to reciprocate. So wouldn't it just be 10? Isn't that easier than seeing the decimal? You could have also said, I have $1, 1, and I'm dividing it by, if I think of this as money, what's 0.1? Like if I went to the store and saw 0.1 on something, that would look weird. What would that be worth? Is it a penny or a dime? It's a dime. That's all right. So I have $1, and I'm asking how many dimes are in $1. I could do it that way if I wanted. So this next one is 1/100th, but essentially I'm asking how many pennies are in $1, if you look at where that decimal is. And the last one, ooh, I'm missing a decimal. A little decimal right in there. And what would that be? Like, how do I say that? You would never see this at a store. You see it at the gas station. What is it? 1,000. So what did you notice about this value of x? It was getting what? The value of x was getting, oh, it's getting very small. It's getting very small. Who's it approaching? It's approaching 0. Would you agree with that? But can I put 0 into this fraction? No. And so calculus says, this limit says x is going to approach 0, but it will never equal 0. It will never equal 0. So that's what calculus allows us to do, is get super, super close. 0 will never be allowed to plug in, but I could plug in 0.000000001. That's still not 0, and I could find a value. Okay? So as x gets super small and approaches 0, what did this relationship 1 over x do? Because this was my relationship. What happened to that relationship? It got what? Super large, didn't it? Okay, so where did it head toward? Infinity. This is just going to grow and grow forever, isn't it? So this is going to head toward infinity. So we can't say it's a value, but it's just getting super large. Super large. Okay? So let's try it with negatives there. And why would I want to try with negatives? Let me draw a number line. You guys can look at the one above. I am heading to 0. I'm heading to 0 from what side here? What side of x? Oh, sorry, when x is this decimal, what side of 0 is x on? The right or the left? These numbers are on the right. Would you agree? Like this might be 1/10. So I'm coming in this way towards 0. I have another path towards 0. What way is that? Not just from literally my right hand, but from who else? From my left. That's right. So in calculus, we just don't get to 0. We have to come in 2 ways. There's only 2 paths. So thinking about what we did in blue over here, what are we going to get here when I take 1 over negative 1/10? Again, I'm going to leave it as a fraction. What does that turn into? What does this turn into? Second one. And the last one? Okay. So as x approaches 0, and this is on the, you said the left, that's why it's in red, what does this go to? This is still headed towards 0, but just on the left-hand side. What does the f of x, my function, head toward? Not just infinity, but what infinity? negative infinity. So I'm wondering kind of what that means here. So if I was to graph this, as I came in from the left, and my function headed towards 0, where did it go? It went to positive infinity, or what did we say? It went to, so can I change that? What way should I go? So here, I'm going to graph this. I'm going to be below the axis. We'll talk about why that is in a minute. I'm headed this way towards 0, and I drop. Would you agree this is negative infinity when I'm on the left? In blue, I was headed towards 0 from the, which direction? It's from the right. I'm coming in. Notice I'm above the axis. We'll talk about that in a minute. And then I head up toward positive infinity. What did I just find there? I've just found, what asymptote did I find? Vertical or horizontal? Okay, so analytically, I found my vertical. Did I also graphically find my horizontal? Okay, so my vertical asymptote is this value that I approach. So my vertical asymptote, and I'm going to write it in calculus notation, then we'll write it in pre-calc, is the value that x approaches. So it's this value right here that heads toward either positive infinity or negative infinity. Now there's a much easier way to find it. So I just gave you a definition. If I go back and look at my function, there is a much easier way to find it. And maybe you remember this from Algebra 2, but I wanted to add some calculus to it. Where is x having trouble? At 0, and how did you identify that? And that value I can't have is a value I must stay away from. So if we look at case 1, we're going to find our asymptotes. I claim you do not have to use calculus to do this. Okay, you can just look at it. Where is my vertical asymptote on this problem? Okay, so do I just say it as -2, but is it a line? It's a line, so it is x equals -2. So if you had to summarize for someone, like if you had to write some sort of paper, are you guys doing seal and laps in English? We're going to start doing them in here. Yeah. If you had to write to somebody, like write a paper, like a research paper or something, where would you tell people to look for the vertical asymptote? Not using calculus, just using maybe just common mathematical sense. Numerator or denominator? So it's where my, what about my denominator? Okay, would everybody okay with it? That's just a way of thinking about it. All right? So now we're going to look at the horizontal. Looks like we already found it, right? Why? Let's look at the calculus way to do it, and we'll figure out why I'm looking at these numbers. So my same function, I'll write it over here. My same function, if I plug a 1 in that denominator, what do I get? If I plug a 1, I get 1/10. And we know that it looks like, I'll put the 0 in there. That would be 1/10, a dime. This would be, I skipped 100, because I got kind of tired of writing this. 0, 0, 1. So let's again look. Where is x headed toward? 10, 100, 1,000. You can see a pattern there. Where's it headed toward? Like, it's headed toward positive infinity, isn't it? Okay. And where is my function headed toward? It's headed toward 0. So my function is headed towards 0. So we're going to write 0 there. You just figured out that limit in calculus. We spent a long time in limits in calculus. So the first time you see them, okay, if you keep thinking, they're kind of straightforward. It's just saying, I'm going to take this table and I'm going to write it a different way. So that says I'm approaching infinity from what side, left or right? I'm going to use blue here. I'm approaching infinity on my right. I would agree with that. And it says my function is going toward what? My output's going to be really close to 0. Will I ever get to 0? No. So let's look at the blue line here. We already had graphed it. As I come into infinity, oh, I'll never get there. I keep going. So this direction is horizontal. Would you agree? And this direction is vertical. So that's why we call it the vertical and the horizontal. So let's look on the red and let's see what happens. What happens when I put in like -1? What's 1 over -1? And this would be -10. This would be negative, how about, I get my decimals right. This would be negative 0.110, tens, hundreds, thousands. So as I come into, let's see, x is headed toward what number? Where's negative infinity? On your right hand or on your left hand? Okay. As I head out to my left, I'm headed toward what? 0. Even though it's negative, it just means you're on the left. So as I come in, okay, as I come out here on my left and go toward a big number, it's settling at 0. So we could use calculus to do that. So this is calculus. The limit as x heads toward a positive or negative large number. That would be calculus. Let's just think of it maybe mathematical sense. What kind of number am I putting in for x? Small or large? So in here, put a very large number. What's 1 over a very large number? Let's just think about that. If I take 1 and divide it by a very large number, what does it approach? Approaches 0. So my horizontal asymptote is y equals 0. Okay? So let's look at case 1. So I'm going to try to find my horizontal asymptote. We said large number for x. Okay, put a large number in there and add 2. What did it do to your large number? Made it even bigger. What's 1 over a very large number? What does it approach? 0. So you just had to do some thinking about that. Let's look at case 2. Okay, so there's 4 things that we're going to be looking at today, and then tomorrow we're going to practice. Today you just have to find these things. We're not going to graph today at all. Okay, could anybody tell me my vertical asymptote from our summary up above? Okay, so let's write as x equals -2 because it is a vertical line. Horizontal says x large. So you're going to have a large number over a little bit smidgy larger number. Would you agree with that? Is it enough to make a difference? So what's that going to go to? It's going to go to 1. So y equals 1 would be my horizontal. Yeah. So just bumped it up a little bit. Yeah. Okay. Well, now we have something new. Do you remember anything about a slant asymptote? This is much more difficult to show calculus, so we're not going to do that. A slant asymptote says that it's not horizontal, that it's slanted. Do you agree? Does anybody remember where that happens? Why? Well, let's take a look here. These x's were of the same power. So if I asked you to do case 3, everybody okay to say my vertical asymptote is x equals -2? If I try to do my horizontal, a large number squared over a large number, like what really is that? Yeah, it's hard to tell, isn't it? So a slant asymptote happens when the numerator has a larger power or exponent. So case 3 does not have a horizontal asymptote. I can't really figure that out. So it's going to have a slanted line. I'm wondering about this slanted line. How am I going to find it? Is there another way I could rewrite case 3? Okay, does it factor? That would be a good option. Does it factor number 3? So how else can I write a fraction? Instead of leaving it in fraction form, guess what we're going to do? We're going to divide, yeah. X squared is divided by x plus 2. Okay, so let's do our long division. What times x is x squared? I could care less if there's nothing else over there. What am I going to put up here? Okay, I'm going to get x squared plus 2x. Remember, we multiplied both of these. What do I do with these columns? Subtract, yep. Negative 2x. Let's repeat. What times x is negative 2x? And I get negative 2x minus 4. Subtract, and I have a remainder. And I'm going to write it as 4 over x plus 2. So this function right here is the same as my original problem. So this in yellow is exactly the same as this. Okay. So when I'm looking for horizontal asymptotes, what do I want x to be? When I'm looking for horizontal, x is going to be what kind of numbers? Positive and negative what's? Way down there, because I'm getting horizontal, big numbers. So let's dissect this. What happens when x is a big number in there? What's 4 over a big number? It pretty much goes to what? So it's not ever going to help me. So my slant asymptote is, because when x is large, that fraction just dissipates and doesn't affect my graph. Okay. So case 1 says we have a vertical and a horizontal. Horizontal was 0. Case 2, if you look, I have a variable in the numerator, but the powers match. So if you look at this, the powers match. If I did long division, how many times does x go into x? Oh, could I do long division on that? How many times does x go into x? I'm going to subtract. Does it still work out that this piece goes to 0 and what's left? And that's what I got. So you could long divide every time if you wanted to. Maybe you don't like to long divide. So what do you do on 4? Yeah, I think we kind of talked about that one without realizing what we were referring to. So let's look at number 4. I'm going to factor that. What's going to happen to the x plus 2? So this is why you did yesterday's stuff. You couldn't graph these without being able to rewrite them. What would happen with x plus 2 over x plus 2? So this rational function simply turns into a what? A line. Yeah. So I'm not going to have that crazy stuff going on. It's just a simple line with a y-intercept of 1 and a slope of 1. However, we still have a problem. Remember what you were doing in WAMAP, and some of us kind of forgot in the beginning? I still have a problem. Even though it went away, it was still there originally. Where's my problem going to be? Is y going to have a problem then too? If x goes in, is there a y that would come out that also wouldn't be working? Who would that y be? Put your x into your new graph, and what would you get? What kind of one? So that is no asymptotes at all. They canceled out. It's a line with a hole. Just a line with a hole. Now that's a lot of stuff. Okay, a lot of stuff there. So let's just turn the page over. We're not going to do any graphing today. We're just going to identify some things. Okay, we're going to identify some things. And I'm thinking we might be okay. But if you look, what you're going to have to find are your intercepts. And I'm going to ask you to find those today. So they're not on this list. I'm wondering if we should add those. Let's add them right in here. Intercepts. Let's add that. How do I find my x-intercept? Who gets to be 0? My x-intercept, who gets to be 0? So some value, you put 0 in for y. What about my y-intercept? That's going to be when who is 0? Okay, so I guess I have a question for you. If I have my fraction, and I have x over x plus 2, and I'm plugging in 0 for my y, how do I solve that? When is a fraction ever equal to 0? Not when doesn't it exist. When is it equal to 0? When what is 0? Ah. So my intercept is 0, 0. What if I change this to x plus 1 over x plus 2, and I set it equal to 0? Where's my x-intercept? When is that fraction equal to 0? When x is? Would you agree? When is my y-intercept going to happen? Plug 0 in, and what do you get out? 0 plus 1? 0 plus 2. So when I heard 1/2, you were finding not the x-intercept, but the y. So I've thrown a couple questions on there because it will help you graph. So let's look at your WAMAP assignment. Can you log on to it? Let's just take a look here. So I can extend dates. I am not worried about that. I just need to make sure that you have some things going on. So I don't know whose this is, but we're going to go into it. And oh, it's Allison's. Thanks, Allison, for letting me use yours. You didn't even know that, did you? But here we go. So here's some questions. So the question says, for each function, determine the long term. Long term, in the long. So what kind of asymptote is the long term? Horizontal. Okay. So I really don't like to divide unless I absolutely have to. So if I look at this, in the long term, what do I know about this relationship? How is bigger where? In the denominator. So in the long term, if I put a really large number in and add 1 over a really large number, cube it and add 2, who's always going to be larger regardless? By a lot or a little? A lot, because of that cube. So if my denominator is always going to be larger, what kind of asymptote do you think I would have? Okay, does a slant happen when who's bigger? Yeah, it's the numerator. So you got 3 choices. Which one do you think it's going to be? If I have a small number over a really large, 1 over 1,000, what's that headed toward? I think it's headed toward 0, huh? Okay, let's look at this one. Here are my choices. What happens if I put a large number in and add $1? Is it about still that large number? And what's the bottom? Is that still about that same large number? What's a large number that's the same divided by another large same number that's pretty close? Okay. And oh, what do you notice about this one? The numerator is larger, so does it have a horizontal? It's switched to a what? So we're going to say no. Okay, check and see if you got that right. Get that right? Okay, so that's what you're going to be doing. We want you to look at things, not always compute. Okay, so let's look at this one. Okay, long-term behavior is the same as a horizontal asymptote. What do you think the first one has? Could you look at it and tell me what you think the first one has? Everybody okay with one? All right. What about the next one? What about the next one? It's a slant, so there is no horizontal. You can't have, well, you can't really have both. We'll talk about that. Okay, what do you think you're going to do on this to find the horizontal? What do you notice about the powers? They're the same. So does everybody agree there's going to be a horizontal? Okay. So think about division if you'd like. The only two things I'm worried about is 2x cubed over 4x cubed. And I'm looking for my horizontal. So when I put a really large number in there, these two have the greatest effect. Would you agree? The biggest power. So put a large number in. 2 larges divided by 4 larges. What is that going to give me? Would you agree it's 1/2? Do you have 1/2 on yours or you have a different one? So try that 1/2. Okay. You try yours. Did you get it right? Yeah. Okay. Look at the one below it. Do the same thing. Why, first of all, or does this even have a horizontal asymptote? Yeah, you said yes right away. How do you know that? The powers are the same. Are you okay with that? Okay, so what's my horizontal asymptote going to be? One large number over 4 of the same large numbers gives me what? 1/4. Try it. Notice it's y equals. They type that in for you. Did you get 1/4? Okay, let's try the next one. Where's your vertical asymptote on this one? What number can't x be that's going to screw this thing up? Okay, so what's this question mark telling you to do? If I'm asking for vertical, what should you type in, x or y? X, so come on. Anybody know what this +6 is going to do on the outside? Aha, so it's really going to be my what asymptote? Up 6, what's it going to be? My horizontal, because horizontal is what letter? X or y? Y, and y is moving up 6. What is this telling me I'm going to do with this graph? Shift it over 4 to the right. So everything you've done before, if we write it in the correct form, we could find it. So did that one work for you? Whatever one you were trying, I don't know. I think everybody's is a little bit different. Okay. What's my horizontal asymptote here? You kind of just found it on this. What's the horizontal asymptote on this one right here? So is it x or y? Horizontal is y. And you said I'm going to take my standard graph and shift it up. What? 1. So this division has already been done for you. Does this look like the answer to the long division problem I did earlier? Yeah. So you get 1. Okay. Let's try the next one. Rewrite in standard form and identify the asymptotes. I don't think you have to spend all that time rewriting. I think you can find your vertical asymptote by looking at it. Allison's is not an integer value, meaning that it's something that's not going to divide evenly or be a nice number. Allison, what's your vertical asymptote on this end? Hang on, vertical is which way? Vertical is, so how do you write that equation? So this is a vertical line, and how do you write that equation? 4x. Which one makes vertical? This graph hits what axis? So it's an x equal line. Okay, and what does x equal? Can you look at what value of x would cause some problems here? -2/5. How'd you get that? Okay. What do you think your horizontal is? I don't think you need to spend all that time rewriting stuff or long dividing. I think you can look at that and tell me your horizontal. What do you think your horizontal is? 25 larges divided by 5 of those same larges gives me what? Okay, type it in and see if you get it. The rest of you okay? You see how she got 5. So this is going to be -2/5 because she solved it. And y equals 5 because she has 25 larges divided by 5 of those same larges which makes that 5. Rest of you, huh? It says that you're wrong. Did you just type in 5 and 2/5? Or did you type it in as x equals? Did you type in negative 2/5, huh? X equals negative 2/5. Okay, question. Do you have a question, Macy? Are you sure? Do you want me to look at yours? We'll look at it. Question. Did you put spaces in there? That should be correct. I think you have to put spaces in, guys. Dang it. Try a space. Yours is right, hun. You just got to put some spaces in there. Okay. We're almost done. Okay. Do you think you can do the rest or not? Okay. I'm going to leave you to kind of think about that. All right.